Hello. Thanks for coming in. I'm firstly going to introduce the topic. This topic is around building your next modern microservice. And we're going to do a few different things. We're going to try to make it interesting. I'm hoping you are coffeeed up. It's 4 o'clock in the evening. I have been thinking about this session ever since I was told that I'm going to be running it together with my co-speaker. And I had this question in my mind. So this might sound random, but if you had to pick between two planets, either Mars or Jupiter, who will pick Mars? So obviously, the rest are going to pick Jupiter. You're going to see why this is important.
Before you go on.
So this is just to make sure that we are compliance friendly, and the lawyers at New Relic, and obviously, Fleet Complete, they're happy.
So before we get started, how many of you are the adventurous type? So just as a little bit of an icebreaker, I arrived here on Saturday. I decided to be adventurous. I walked all the way down the strip from one side to the other. It took me about 2.5 hours. I got to see it throughout the whole, while the sun was out. I decided, well, it got dark. I can do it the rest of the way all the way back. So I did my 2.5-hour trek back throughout the night, got to see all the nice sights. What felt like everything was fine, go to bed, wake up the next day, I'm like, my foot feels a little off. 24 hours later to this morning, sure enough, there was a swollen foot and a nice bruise right there. So as part of the adventurous flow, a couple of guys that you have up here, my friend Nick, against my wishes, decided to do not one, but 2 live demos today. We know how we can always run into technical difficulties, but he is the adventurous type as well. And those are a couple of guys that you have up here.
Yeah, I want to keep this educational, so the more I can show you, the better. But in terms of my introduction, I'm from Melbourne, Australia. You don't hear the accent. That's a story for another day. In terms of my background, I have been a developer. I started coding financial services software, built collection management systems for banks across Malaysia, Singapore. And then I bumped into the classic, burning the DVDs and passing on the software to release managers. And Monday morning, the first thing they do is they ring my mobile. So from that time, which was more than 10 years ago, I had to find tools and techniques in order to do that better. So what I ended up doing is, I went into consulting, and I started off as a release automation. Even before DevOps was a thing, there were a couple of tools out there, so I consulted them, and then eventually landed into managing software. So the other thing that I want to share with you is I thought the way to rise the ladder is get a management degree from the top 10 business schools. I am on the way there, but then it's almost like revenge of the nerd kind of situation. So what I started observing is being devish is more cool. So I started picking Kubernetes, Golang, Node.js, Docker, just to stay relevant. And Javier, in terms of your intro?
Oh, absolutely, if you can just. Yeah. So my name is Javier. I come from a company called Fleet Complete. And we're a leading global provider of IoT solutions, fleet-based IoT solutions. And we really help fleet thrive on having connected vehicles, monitoring their assets, things like equipment, as well as your mobile workforce, so interacting with your mobile workers on their mobile device. And as part of this journey, I started off in the support area, kind of accepting support and deployment, kind of accepting the DVD from Nick and putting it into our production systems, making sure as an IT ops guy also that the servers were up. And throughout that journey, before DevOps was a thing, we were already trying to see how can we take this DVD, how can we take these files and make our lives easier instead of doing manual labor on the server side. So a lot of what you're going to see here is where have we gone from that to where we are today?
So in terms of the agenda, we've broken it down into 3 stages. So there's the walk stage, where we'll literally show you how you can build AWS native services. The intent there is to take you all the way from ideation, experimentation, then deploying a service, hoping to scale the service, managing the service, and then, because good enough isn't good enough, we want to talk about the guiding principles and the observability strategy that can help you to do this in the most perfect way. And obviously, there are no one way about it. This is just what our experience is. So we're going to share some of that with you today. So, I'm a big believer in philosophy, and I don't want to make this a philosophy session. But I'll always think about, in terms of building a service, there's a laundry list of things you can do. So if you think about how do you want to build a service, you want to start with the why. Because if you think about what your businesses are trying to achieve or your company is trying to achieve, how many founders do we have in the room? And maybe they will agree with me or not. Any founders in the room? So typically what we keep seeing is you firstly want to ensure that there is a product market fit. The second part they want to make sure is per transaction, whatever transaction they are servicing, they should be profitable. And the third thing they want to do is, while serving those transactions, they want to do that elegantly. Otherwise, it will create a leaky bucket effect. So same with software development. You want to start with the why, then work into the what's, and then finally go to the how. So if you don't really need a supersized, scalable service, you might not want to use certain options out there. And that's the whole idea. Maybe take a step back and think about why you are picking a certain service versus all the other options in the market.
And to piggyback off of that, it really helps to paint a picture. So as Fleet Complete, we went through a massive transformation over the last number of years. It took us 12 years to get to 70 employees and only a few years longer to get to almost 500 employees. So the growth rate has been accelerated tremendously. And throughout all of this journey, it was also a growth rate of the number of services that we were supporting. So you have your typical monolithic application that companies have started off with a long time ago. You start to break apart that monolith into all these different microservices, and all of a sudden you find yourself that all the different dev teams want to use the niche technologies for their particular service. You start to get into a whole ecosystem of new tech stack. Now, somebody needs to manage all this tech stack. Somebody needs to also have all the monitoring and alerting. And this is where Fleet Complete took a little step back and said, hey, we want to make use of the best technologies that are out there. We want to be modern. Let's partner up with New Relic and our AWS partners, and then let's go and think about what is the next modern stage that we can look at. We have this huge operational overhead on all these different services that we want to have, and then now it comes time with, do we really want to have resources that are out there maintaining and managing these resources, or do we want to be truly modern and go down to the native services where?
Cool. So that brings us to our walk stage. So before we look at how you could develop some of these services, you want to define what are the core ingredients of some of these services. And I think it's easy to agree to DevOps being one of the core tenets, in the sense that you need to leverage a code pipeline rather than doing things manually. And I know for DevSecOps, people who are sold to that concept, and which is pretty good, you also want to think about security, and Istio and service mesh and all other security principles are not in the scope of this presentation because it would be a huge talk on its own. So we moved to the autoscale dimension or endowment of a modern microservice, and you ought to be able to use autoscale in your service as well. The third part is you want to make it cloud native, and there are obviously ways to have cloud native workloads on premise. So I'm not saying cloud native as in on the internet. Orchestrated is one of the other important aspects, because a lot of these services are container-based, and you're breaking up VMs into a lot of different containers. So you don't want to manually manage them. And you already know this. I just want to see a show of hands. How many of you are using container orchestration services? And have most of you developed on these services, or you are managing these services? So developed, show of hand? Cool. And in terms of those of you who manage these services? All right, beautiful. So now let's hear a Fleet Complete's variant of the same problem.
So just to piggyback off of that, at Fleet Complete, it really started off that transformational journey between that handoff to really working and shifting left. So we moved let's say our deployment team into the development team and started really driving down the DevOps mindset. That touch point with developers, making them feel a part of the accountability that you have to put your application all the way into production. And as part of that, we started touching base on, this is the way that we were working before on pizza boxes. This is how we worked when we ended up with blades, thinking of things as just compute. The next level is obviously going into cloud computing. Some of the things that, when you move from monolith, you obviously have your EC2 as a basic understanding of auto-scaling. That's a very easy way to understand what auto-scaling is all about. You have a particular image of your front-end web applications. You can scale them out as your needs require. As part of analyzing what we were doing and how we were scaling out, we decided along the lines of how can we be even more cloud native? How could we push our boundaries, and how do we really embrace AWS as our partner? Started looking at things as, definitely just based on consumption. We don't want to deal with pre-cut images. We want to deal with the world of containers. We want to deal with the world where we don't have to manage infrastructure anymore. And part of that was looking at technologies like Lambda, like CloudFront, to offload our static files and some of our low-hanging services. And then really, when you have all of these containers set up, you have all these microservices, you have all that tech stack that you want to run, how are you going to do it in an efficient way? And that orchestration really is obviously the next level of things. As many of you have pointed to, there is some level of orchestration already happening. It's been out there for a few years. And one of the things that we won't touch base on here, but on top of all of this, encapsulating everything is, what about security as well, right? So we won't touch base on the security part. It's a very large topic, but even that comes into consideration.
So now that we hopefully agree on what a modern service looks like, we want to talk about some of the best options out there. So Amazon EKS, AWS Lambda, and AWS Fargate is what we chose to build the service that we are going to demonstrate. And the benefits we saw outright were along the lines of least operational burden. That was priority, because we want to do more exciting things like automate, faster feature delivery to the market. Second part was we love the utility model. Like when I built the demo, and it's still out there, it took just $5 to run it for the next 15 days. And the moment I added a lot more pieces, obviously that price went up, but it was still something that I could have paid out of my pocket just from a demo perspective. And in terms of productivity, what I like the best is it abstracts a lot of the gory details from your service itself. So, a lot of my customers that I work with, they tell me it's almost like these services make us lazy, but in a good way. So I also want to introduce to you Fleet Complete's angle to these benefits, but hopefully you concur.
And the great part is, a lot of these things, sometimes we like to quantify in dollars and cents, but that's not always the case. And a perfect example is, operationally, you're dealing with all these different services you need to upgrade, you need to update the OS that they're on, you need to maintain those security cadence. You have resources dedicated to that. There's a lot of headcount that goes towards just maintaining what you have. Imagine the world, obviously, of having hundreds, if not thousands of containers out there running on all these different hosts, and you managing all of that, preparing your upgrade cycles, update cycles, and all of that while maintaining uptime. You're running into situations where, it's obviously you're going to not be able to scale. So some of the cost efficiencies that you get is you get those resources back. And we want to really take advantage of the fact that now those resources can be taken into consideration for things like New Relic's a new app store, which they have a cost optimizer. So we can actually look at other ways to improve our actual cost, being cost efficient. And part of that, the whole New Relic platform is now we do have a whole bunch of different services that we are monitoring. How do we monitor them better? How do we create your single pane of glass that everybody talks about? And one of the things that we found as part of partnering with New Relic and AWS is that we're all on the same page. They have the tools, they have the tech stack to be able to go ahead and use all these native services and be able to inject that into a single dashboard, a single tool that we can actually use to monitor the health of our applications, pinpoint when situations arise, and actually have a faster time to resolution. And those are key things when you think about the reasons why our customer use our product is because they want to see where their vehicles are. They want to see where they're, and it has to do, I'll give you a couple of stories too. It's, we do have some emergency services online, or even when it's not emergency services. We had a client that was just literally driving down the street. They expected a driver to arrive at a certain destination. He was late. All of a sudden, the dispatcher says, hey, where is this driver? Why is he so late? Well, he's always on time. What's happening? They took a look at where the location was. They noticed that he was on the side of a highway, immediately pinged the driver, wasn't responding, called 911. He had ended up having a heart attack. So there's a life component to this, and this is why we really need something that's mission critical, always up as much as it can, obviously within reasonable constraints, and having New Relic and AWS understand that world for us really helps us build a more robust service. For example, because we are IoT heavy, IoT Core is one of our larger services that allows us to scale. We have millions of data points that come in every single day. As part of those data packets that we get, there's tens of different sensory information that we get for whether it's vehicles or mobile devices, whatever the case may be. So that creates billions of data points that we have. All of that needs to be monitored. All of that needs to be ingested. And working with these kinds of partners that really understand the business and understand scale. Obviously, Amazon can scale very well. We want to take advantage of that and help us grow along with it. Again, by maintaining operational overhead to a minimum.
Great. So it's game time. This is the fictional situation due to which I asked the question, would you go to Mars or Jupiter? So imagine there's a fictional situation. We are in 2045. Everyone is kind of talking about it right now. The Earth is no longer livable. And there are 65,000 people chosen to be able to go either to Mars or Jupiter. And you're all the chosen ones, so you don't have to worry about reserving your seats. But what you need to be able to do is send your last wishes to the ones who are going to be left behind. So it's a little bit emotional, but I don't mean to tap into your emotional centers. What we want to do is crowdsource some of that traffic when we get into that phase. So next up is the architecture that I chose for this application. I built upon one of my colleagues' existing work, and I was like, how can I make it more interesting? Adhering to all the best principles and the core ingredients of a modern microservice, we decided to choose a Node.js frontend, talking to a Lambda parser function, which does all the data massaging, and talks in turn via a queue to the pod worker, which ensures that these messages are persisted, and they are out there. So this is the application we built. We now want to get into our first demo. And let's do some traffic generation. So if you pull out your phones, I want you to break this app. And I deliberately made it flimsy. I think it's going to break. But let's see what happens. Right after you have done this part, we will firstly show you how this application was provisioned and enabled, and then we're going to go into our second stage. So anyone got to submit their last wishes? Yep, we see some yeses. Anyone on Android? How many Androids? Yeah, you will expect some errors. That's, I'm not too pricey about one or the other. I'm happy with both. I just had the code handy, so I plugged it in. Now, let's go to the demo piece. You've obviously generated some traffic. I'm going to run load generation on top of this. But in terms of how did we build and provision the service, we build CloudFormation stacks. I'm not doing all that work by running all the scripts. But what I would like to do is have one CloudFormation stack to automate the provisioning of the backend ecosystem. So DynamoDB, SQSs, Lambda, the VPCs, the security groups, the roles and the permissions, all of that stuff. And the second stack I deployed is the cluster itself. So we enabled the EKS cluster. That also gets a third stack, which will basically comprise of all the node groups that are supposed to report into that control plane, which is managed for you by AWS. So let's click on the third stack just to show what sort of resources were developed in the process. So if you hit the resource tab, it's going to show you all those components that make up this application, including the ecosystem, the permissions, the VPC setup, the security groups, and all that. And if you feel like you want to emulate this in your own environments, I did put together a GitHub repo with a project plan. I'm running a little light Kanban and my own dev pipeline. So you can even contribute to it if you feel up to it.
And as part of that demo that you guys were using on your phones, it's really adding that SQS services. So just as a quick example here, you can definitely just type right into an SQS queue, put my message through, and you'll see that it's been sent into the system. So one of the things that we want to grab is we'll take a look at our DynamoDB, and we'll see what kind of messages are in there. You can see that the message that I just submitted, as well as other ones that have been in there. We can now see our messages are in that queue, and they've been assigned. So just quickly going back into our presentation.
These are the key takeaways. But before I get to the takeaways, who amongst you are using CloudFormation today? And are you doing similar things? Show of hands for yes. Right. So why I ask that is because I feel, as a part of thinking about operational burden, part of the operation is to manage, and there are quite a few cloud admins amongst us. So CloudFormation templates make that whole job of managing the service and making sure the provisioning happens in a seamless way. And even if you want to push updates on top, that happens seamlessly as well. And I'm running a workshop on this on Wednesday, but we'll talk about that later. The third takeaway is we have gotten past taking this from ideation to experimentation and pushing it out in the marketplace. So we are done with the walk phase of the demo. Hopefully it made good sense. We now want to also think about, now if the service was crashed by your traffic, how would you manage it? And if you were able to rewind time, how would you redo the definition of a modern service and then go all over again? So that's the next part.
And with that, you got to see this slide prior. We'll trade spots so you can.
Yep, I can navigate.
Yep. So you just seen the application. It's a set of AWS native services, and that's great when everything's humming along nicely. As you're building a house, you always want a good foundation. So as you can see in the slide, there's a new Relic foundation amongst all of these services so that you can have that level of observability that will give you insight into, if anything does happen with your application, what are the different steps that you can take to actually resolve it. Did you want to do that?
No. So the other thing we wanted to highlight to you is if you were to redo the definition of a modern cloud service, you want to add a bedrock of observability. You can draw on the metaphor of how buildings are made. And if you talk about Burj Khalifa, It has really deep foundations. So it's kind of like that. Now, in terms of the instrumentation effort, you pepper your entire architecture with different agents. So you start with the front end. Now you have access to that front end on EKS. So you're able to deploy a pod that monitors EKS together with things like OpenMetrics, Prometheus. You can jam it all together and then marry it up with CloudWatch, which can natively watch services that you don't have access to in terms of a console and see what's under the skin. You then move to the Lambda functions. You deploy app agents on the Lambda functions as well, and same with Fargate. So if I now redo the whole demo, this time around, I'm going to focus on the management of this service. And assuming that you broke the app, I also ran some load in the background. If the app is broken, we want to find out why did it break. And this happens to us all the time. You push an idea out in the marketplace. Users start to take that service seriously. You see exponential or linear user growth, and then you don't know how to scale this. So what happens is, instead of innovating, you pump hard brakes on your innovation cart, and you switch sides into the stability cart. And I see it happens with startups, scale-ups, and grown-ups. I'm not saying startups aren't grown-ups, but I think in order to make sure I sync with the suffix, I had to come up with a replacement for heavyweight companies. So let's do the demo part, and I will navigate this time around. So this is a service you saw. I don't know if it's still up, but let's check. It's surprisingly still up, but I see some weird stuff was sent by someone cheeky amongst the audience, an iframe. Luckily, I managed that in my code. So if I now say, I can still see some messages coming through, which is good. So if I now want to manage this service and see what's happening with the service itself, this is the console that we typically rely on. It's a cloud-native console. It's a light-weighted UI. It's all React apps. Most of the apps are provisioned by us for our end users. And the objective is we decided on a UI SDK approach, a programmable platform, so that if you have React skills, you can push your own apps on top of our UI and then visualize data in your way. But if you don't have those skills, there are lots of applications readily available for you. So the first piece I'm going to walk you through is what I refer to as areas of concern. And there are a lot of SRE leaders, old school support folks, and even the more modern type of roles where you have to be a general specialist. This could be a view of all the things that you care about, and we refer to this as your workload, which is why we gave it the name workloads.
And as an example of workloads, as part of developing a microservice, really there are loosely coupled services that maybe other teams might own. And this is one of the features that we really enjoy about platform New Relic One. And it allows you to really define a dashboard for that particular team. And what I mean by that is when they're accountable for something, they're able to now see not just their services, but their other team services that they rely on. So you can easily, when there's a problem with one team's application, they can see if it's their problem or another team that they need to engage as well. And it makes it very easy to have different dashboards for different teams.
So it's almost like looking at that same architecture we introduced in the walk phase in a disintegrated way. And the second thing it does is it automatically annotates these constituents of your modern service in terms of what's on fire right now. That's the first thing it answers. The second thing it answers is what is alerting. So on the right-hand side, if I'm being told the host is on fire, on the right-hand side, I'm being told why the host is on fire without switching screens and losing that context on the host being on fire. The second thing you can do here is if you scroll down, you'll start to observe. We always talk about that single pane view and one view that will solve all your problems. I mean, my opinion is it doesn't really exist, but this is as close as it gets because it automatically grabs the most important SLIs for your hosts, for the Lambda functions, for the queues, for DynamoDB, and it prints them, shows them in these layered charts as you scroll down. So this is the real-time consumption of your Kubernetes cluster in terms of CPU and memory. And if you keep going down, it will show you if your Lambda functions are invoking. The second thing you can do here is if you now want to go deeper, you can pick the list of entities. Everything is an entity within our observability platform. So you can look at all the entities that make your application and then click and drill in. So I've got a little bit of a second story to draw on the space analogy. How many of you have heard about NASA's Sentry program, Earth Impact Monitoring? So what they do is they have telescopes watching for NEOs, near-Earth objects, and they are fireballs, asteroids, all those things that could wipe us off. And what they do is they watch them 80 years, 100 years into the future. And the program director says there are two things you need in order to do a good job of this. So he feels that you have to have telescopic patterns, and you need to have seismic sensors on Earth for smaller objects or smaller problems that escape or are not detected on the telescope. So to draw those principles, he boils it down to two things. So telescopic patterns and microscopic patterns. That's exactly what I'm going to demonstrate next to you. So this is the telescopic view of your EKS. There are 3 nodes in there right now. And I can click on a particular node service and see what this node is up to in terms of the most important SLIs. I can then say, I want to go a little bit deeper. I want to see what's really happening on this host. And I can see that memory consumption hit its limit. And if I scroll down, I can see which processes cause that. So you can sort and see what processes are consuming a lot of service. And if you jump back out, you could now go microscopic. So my most important app here is my front end. So there's just one copy, one pod of my front end. I can now say, I want to see what's happening on this front end. And it then shows me 2 things. It shows me the log view, and it shows me the pod events. So if I click on the log view, it will show me 3 seconds by 3 seconds what's happening on the pod. And the good thing here is it's elegantly managing all the messages that you sent. If I then click on this pod and filter by the container name, I could do something like this. And this is all in context. In fact, I double filtered it, but doesn't matter because it's going to work. And then I said, show me some errors in this container. And it seems like somebody sent a JavaScript function in there as well. So we captured it. And there were some errors surrounding this function. It'd be nice to meet you in person, whoever that is. You are very efficient. The next thing we can show you here is what happened with this application from a pod level perspective within context events. So I clicked on the pod. It went from telescopic, second level, and then microscopic. And now it's showing me an image was pulled at that time, then container was created, and then restarts happened, so you broke the app. So it's telling me restarts happened 16 times in the last few minutes. And I could even go further, and if my app comes back on, I can see distributor traces, the request flow traces, right in this view. But I can always jump back out and say, I want to see my distributed traces pattern and see how the calls are being processed. And then I can say, I only want to filter this for my space app service. So that's the service. And then now it's showing me all the traces that were collected for your efforts in generating the traffic. So I could sort by a variety of things here. There was one trace which was super long. I don't know what went wrong there, but it's good because it served the purpose. And the second thing I could do here is I also want to filter for errors. And I might want to jump back in time. And I can see that if all the Android devices related traffic was collected, then you can even expand into the errors that point out you used the wrong browser. So the user used a certain browser which is not supported for this application. And we saw all the way from what's happening in the pod with what's happening from a user experience perspective and everything in between in form of those stack traces. So now, we talked about managing the application better with a bedrock of true observability. The third thing you could do here is also reclaim some of your wasted compute related dollars. So here, you get an in-application optimize option. So when you click on this, it looks at your application. It identifies what are the resources dedicated to this application, and then it automatically suggests and make recommendations your service is supersized. You would be happier in terms of saving some money if you drop the service from a T small to a T3A micro, and it will still scale beautifully. The second thing it's pointing out is the total number of container statistics and the max daily unique container stats, and the list kind of goes on. The last thing I want to show you from a demo perspective is I'm talking about in-app optimization, but the app sits on your Kubernetes nodes. So why not begin your optimization efforts on the worker nodes itself? So this is what this particular open source application does. It's called Compute Optimize. And it supports multi-cloud, but we first launched it with AWS. And what it does is it's now telling me, based on the instance types that you have within your environment, you could reclaim $449. And if you want to see what those details are, you could click on the tile cards, and you could export this report, and then either you want to run it by your cloud team and point it out to them that, I looked at our peak traffic trends, and yet I'm being told that we can reclaim some of the cost to provision this service. So this is how I would basically support the ideation, experimentation, launch in the marketplace. And even if you are already out there and you are halfway into scaling up your service or scaling out your architectures, you want to think about these kind of patterns regardless of the platform you have on hand. And I don't know if all the use cases are portable in your own observability tool, but at least from a fundamental perspective, a lot of this knowledge is portable. So let's go to the fly phase. Do you want to add in something?
Yeah, I wanted to add, how many people are actually on call? Couple of hands? All right. Yeah. So as part of being in the on-call world, one of the things that I find beneficial is the smartphone, right? You have your phone on you all the time. You want to be able to do as much as you can with that phone. And the beauty of having as many tools within one tool is you have one place to go. How many people love to, go into a logging tool, go into a health check monitor, go into AWS, take a look at your CloudWatch logs. You don't want to go to all these different places, and you actually, it actually reduces your time to resolution. So having that capability for all the on-call staff to just take a look and say, is this for me? All out of one shot, that is invaluable. especially as you grow and you scale, people can now target that resolution. Do you want to go back to this one?
So it's time for takeaways. And the first and foremost takeaway is leverage easy-to-use wizards and tools for full observability. If you divide your context across tools, you lose out on how quickly you can repair. The second thing that a lot of folks don't do, but it's super valuable, especially from gamifying your engineering, is codify your monitoring and monitor your code pipeline and bring in those details in here as well. So what I did for this project is whenever I push new code into my GitHub repo, Docker Hub is listening to the changes in my repo, and it automatically builds a new version of my application. I then automatically update my application by rolling over one instance after another. So basically replacing the pods. The third takeaway is, now we talked about this frictional situation, and this is not a pun, but if you keep the compute lean, we can keep the planet green, right? So don't do it to save your dollars, but do it for the planet. Now, if we speed up into the last phase, which is how would you get into flying mode if you're already in the run mode, then there is another little strategy that I want to share with you, which automatically gives you all your key constituents in order to run your operations. So this is something that I came up with after listening a talk by GE at one of the conferences. And there was a concept of failure modes and effects analysis. So what that concept does is it borrows from engineering principles, and you basically ask around your SRE teams if you execute the SRE function, or your operations team, and check what are the failure modes they're trying to solve on a regular basis. You then grade them by 3 different attributes: the detection of those failures, how easy it is to detect, how often do they present themselves, and how severe are the problems when they emerge. You then multiply those references, and every single dimension is graded between 1 to 10. So you'll get a product which will be a max of 1,000. Whichever failure mode gets a max of 1,000 means this is the type of problem that will cause a mayday for your service. So what we do is, you see those RRNs, those are the results of the multiplication that I just explained, and that gives me my priorities. I can sort by the risk reference number and deduce which failures are most critical for me. I'm then able to decide what is that measurement that I need, which is the SLI I need on my dashboard in order to make sure I keep an eye on that failure mode. Although I would argue that's a great strategy, we're not made to stare down at dashboards. So use your alerting strategy as your go-to place. So what I mean by that is, you now have an example SLI, like in the case of slow page views, you might want to look at your 95th percentile page view time. And then the SLO is, I want to serve 99% of my transactions under that 95th percentile time, or under the 99th percentile time. So you can then methodically deduce all your SLIs and SLOs, which sound like jargons, and then gear towards your SLAs, which is how your companies, and especially the business side, the expectations they have from the operation side. So you can tell them, you're expecting 5 nines, but we are doing 2 nines. I can give you 3 nines at best in the next couple of months. So keep the whole process honest. Would you have a comment on that?
Absolutely. So as part of using dashboarding, you definitely want to use it for the business as well. So having these numbers up on a New Relic dashboard really helps to drive that message through. How many people actually incorporate performance testing as part of their CI/CD? Few hands. So really, to drive down and to really understand, objectives are nice to have, but how do you measure them? How do you get to them? Could this application that we built today have benefited from a performance test? Obviously, it would have found that it couldn't scale up properly. It ran into issues. And I think as part of incorporating performance into your CI/CD, it allows you to give better thresholds to these numbers. And then you'll be able to truly prove where your application really stands. As part of that whole DevOps CI/CD mindset, as you start introducing new tools, you always look at what lies ahead. And as part of that, you always think, what else do I need, right? In the last few years, security has been a very big thing. You want to start incorporating some security tools into the mix. And I think that the way that it's going to go forward is not only is it going to be DevSecOps, but we need to look beyond that. That's already been there, done that. We already know what security is. And we really need to look at what's the next step. So I'll leave you with that. We have a couple of quotes for you.
I've got closing thoughts for you. So I'm a big blog reader, and highscalability.com is phenomenal if you're trying to learn more about what you can do in your particular situation. So I bumped into this quote. It says, the best way to speed up a website is almost always to add cache and add some more cache. And I think that the real response is you also want to add AWS and an observability platform like New Relic to your equation, and then you can truly harness the power of performance. With that, we really want to thank you for staying by. It's kind of late in the evening. I'm pretty sure you're worn out. So thanks for listening.
Thanks, guys. It's been a pleasure.